Hello, this is John Black, Super Chemist. I'm going to try to make some calcium oxide. I got some calcium carbonate here, 2 grams of it. The reason why I'm doing this is I want to make sure that it's all carbonate. Could still be some hydroxide in there. Now, difference between calcium carbonate and calcium oxide is 100. Calcium carbonate is 100.087 grams per every mole, right? But calcium oxide is only 56.08. That's almost half. You know what I mean? It's 50 would be half, and it's 56 grams. So if I have 2 grams in here, right, I should be able to heat it up, and it should go down to like almost half. If I have 2 grams in there, it should be like a gram and maybe a quarter gram, right? Now, calcium carbonate, this is called calcination, what I'm doing, right? But if you have calcium carbonate, you need to get it up to 825 C for this to happen, this calcination. If you have calcium hydroxide, you need to get it up to 512 C. But then you'll have water there, you know what I mean? And I've never done it really with calcium hydroxide. But we're just going to heat this up and see how it goes. We'll get a weight after it. You can see there's no water on the test tube. If there was water on the test tube, you know, you'd see little droplets. That would mean that this was not all calcium carbonate. Some of it is calcium hydroxide. And as you can see, there's no well, let's do the math. It's pretty simple. Looked up my molar mass at, on Wikipedia. I got these numbers here. Obviously, I took them down to these numbers because that'll make it nice and easier. I don't even need a calculator to do that. It's 56%. Just in case you don't know, you take the bigger number, divide it into the little number, and you get that. Move your things over twice, your decimal, and you get your 56%. So that basically means that whatever my calcium carbonate weighs, my calcium oxide, when I get done with the calcination, should weigh 56% of what it did originally. So I just weighed mine up. I have 71 grams. So I took that times 0.56. I got 39.76, which obviously I raised up to 40 grams. So once I'm just going to heat this up. This can I got at Walmart, like in the fishing and hunting section. Got the little handles. You can actually move these handles so it goes around the cup. So you just put them in storage, and then you take them up to the handle. Well, nothing really exciting is going to happen here. It's going to take a while. When it does get up to temp, I will come back and light a match and see if the carbon dioxide, takes it out. There's another special thing about calcium oxide is that if you take it up to like 2,400 degrees, let me see, heat to 2,400 degrees Celsius for limelight. Back in the day they had, they didn't have electricity, so when you had theater and people were on the stage, they would use limelight. You know what I mean? Oh, you're in the limelight. You ever heard that expression in like movies and stuff? What they do is, I think what they did, I'm just guessing here, so don't quote me. They did a little bit of, they had like a little electrolysis box that made hydrogen, and then they used a blow tube for the oxygen, right? A blow tube, and they'd blow in. They would make the hydrogen from the electrolysis. It would come up. They would blow oxygen through, and that would make an oxy-hydrogen torch, just like an oxyacetylene torch, only you're using hydrogen. And it's up to 55 C, so I've got a long way to go. But anyways, and that would make it hot enough to get, because that's a lot of heat, 2,400 whatever Celsius. Heat the calcium oxide up, and it would make this bright, super light. And then I guess they used tin or mirrors or whatever to, you know, make the light go out, you know, reflect onto the stage. So nothing's really happening here. Let me try to stir it up. It's definitely no water in this. I mean, it's definitely all carbonate, not hydroxide, that's for sure. Let's see what the temp is now. 167, 174, 165. Well, I'll bring you back when it starts being hot enough, and then I'll light a match, hopefully, and it'll go out. Alright, I tried doing this on the oven. It didn't work very good, so I switched it over to this propane setup here, the Bunsen burner. It didn't work very good either. What did work good, see, I got my product in here, right? Oh, you can see that. I want to dump it. Anyways, I put it on the hottest part of the flame, and I got this. Let me get a better hold of this. You can see the whole thing is getting red hot. I don't know if you can see it on camera. Okay, that did work, but it's taken so long. I mean, I'm putting this thing over the flames for, 10-15 minutes just to get a couple grams off, and I got to go from 71 grams down to 40 grams. Right now I'm at 59, so it did go from 71 down to 59. Do I want to sit there forever holding that crap, and both the torches and that? No. So I got my kiln out, but I did show that it is possible to do it with that. It just takes forever. So if you got a foundry or you got a kiln, that's the best bet. See, I got different layers here I can take off. Got my thing. Put it right in there. Okay. Cap it up. And plug it in. Well, this is after 20 minutes. You can't even see in there barely. Oh my God, it's so hot. I've had it in here about an hour. Whoa! I don't know if you can see in there, everything is glowing red. Glowing red. Okay, I'm going to have to close that up. So there it is. I took it up after an hour. Probably took 10 minutes for it to get up to temp. You can see I put a couple flakes here so you can see it. It's real thin, but you can see it's inside the thing. That can that I had it in, oh my god, it just burned it to pieces. And little pieces flaked off and stuff, so, you know. But it did work. It actually didn't come all the way down to, it should have came down to 40 grams, but I got like 46 grams or whatever I said. See what I mean, I'm going to do the same exact thing, I just need a different container. That container sucked. I just wanted to show you what that cup from the last video where I did a calcination had calcium carbonate and heated it up till it decomposed into carbon dioxide that left, and I was in the pot would be left calcium oxide. Now look at this. This was brand new, nice and shiny. I never used it. Look how it peeled off the. I don't know if maybe now it's good. Once it peels that crap off, it won't peel again. I don't know. If anyone knows, let me know, because maybe I'll sand this down or something and put it back in. Maybe I don't know. And you can see I left some calcium oxide in there, as you can see. But you can see all the sides and that it's just flaked off, man. Stuff just all that fell into my calcium oxide and ruined it. And I can't think of how to get it out of there. Oh, maybe a magnet. I'll try a magnet, but if that don't work, I mean, I can't put it into water because the calcium oxide will turn into calcium hydroxide. Alright, I wrapped my magnet up in a paper towel. I should have put so much maybe. So it doesn't all stick to the magnet. Oh shit, yeah, it's getting it out of there. Oh hell yeah. Or, I shouldn't swear. Alright, well you can see how I'm going to clean it out of there. Look at all that metal there. I got some more. You can see it's getting whiter and whiter. You get the gist. Look at that, it's nice and whiter now. You can barely see anything in there. I mean, there's still stuff in there. I'm going to clean it up better. Check it out. Thank God, now I don't have to make some more, do all that again. Anyways, y'all have a good day now, and always remember science is great.